Hello. This is a problem working session, and I'm going to work some of your homework assignment problems, and I will also explain everything that I'm doing and how I approach the questions. And hopefully you'll learn from that watching this video. So the first problem we're going to look at is Chapter 3, Problem 1, when I accessed it at least. Julie has a low credit rating, plus she was furloughed from her job 2 months ago. She has a new job starting next week and expects a salary to start again in a couple of weeks. Since she is a little short on money to pay her rent, she decides to borrow $105 from a loan company, which will charge her only $10 interest if the $115 is paid no more than 1 week after the loan is made. What is the effective annual interest rate that she will pay on this loan? Okay, so let's assume that since it's such a short-term loan, that she's just going to pay simple interest. She's going to pay it back in a week. It's hardly time to compound anything. So I'm going to start by saying the future value when you're dealing with simple interest of a present principal sum, which is what we have here of 105, is the present value plus the interest that you earn, and a capital I means simple interest. And remember, the formula for capital I is PIN. Okay, so this will be the present principal sum of $105 plus P times I times N. And N is going to be 1 week, so I must be the weekly interest rate. And we know P is 105, and we also know F is 115. So let's plug those values in. So we'll have 115 is equal to 105, that's that one, plus the I, which is 10. But I'm going to put it in as 105 times the interest rate per week, this is weekly, times the number of weeks, which is 1 week. So what we're going to end up with then, on the right-hand side, I'll factor out the 105, and I'll get 105 times 1 plus I weekly. Okay, so what we're really looking for now is I annual. What is the annual effective annual rate? So let's first divide through the equation. Actually, let me. I shouldn't have factored this out. Let me leave this here. Let me cross this out. Let me just subtract the 105 from both sides of the equation. So then I'll have just $10 is equal to, excuse me, 105 times I weekly. And so if we divide through by 105 now, we'll get 10 divided by 105 equals I weekly. And so if we compute that out, I weekly equals 105 divided by, 10 divided by 105, which is 0.0952, and then there's a lot of decimal places, 381. if we want to carry it that far. So the I weekly is roughly 9.5%. But what we're going to do is say, well, since that's the weekly rate and we're only dealing with 1 week, we're going to let that be equal to our R weekly as well. Remember, the R is the nominal rate. But since there's really no compounding, the nominal and the effective are the same. So the nominal rate is also 9.52%. But now to get the the effective annual rate, I annual, which is what we really want, remember the formula 1 plus R over M to the M power minus 1. That's the effective interest rate formula. So this is going to be 1 plus R annual divided by M to the M power minus 1. Well, what is M? Well, M is going to be 52 weeks because, in fact, if you're compounded weekly, that's what M would be. So we're going to let M be equal to 52, and R annual is simply 52 times R weekly, right? So this is going to be nice and easy to deal with because this is going to be 52 times 0.0952381 divided by 52 to the 52 power minus 1. So we're going to get I annual equals the 52's cancel. So you're going to take 1.0952381 to the 52 power minus 1. When you do that calculation, you'll get 113.3559, and then when we subtract the 1, we end up with 112.3559. Well, I equal 112. Remember, this is the number. If we put it as a percent, we move the decimal place 2 to the right. So as a percent, I annual will be equal to 1,236%. Wow. That's your typical loan shark deal right there. The next problem is problem 3.3, or chapter 3, number 3, when I access the problems in your homework assignment. And it says you have a very good salary and a smart investment manager. She tells you that in only 6 years you can accumulate $688,530 from quarterly deposits of $20,000 excuse me, into an account that has a historical return of 12% per year compounded quarterly. So you're making excuse me, you're making quarterly deposits of $20,000 and you have quarterly compounding of interest. It seems like a stiff commitment. Yeah, $20,000 a quarter, that's a lot. But one worth trying as you prepare for an early retirement from your current defense contractor engineering job. You are a cautious investor. Suppose the market does not perform as your investment manager predicts, and the return is only 50% of what she predicted. Now, she predicted 12% per year compounded quarterly. Now, what is the future value of your quarterly deposits? So we're looking for F, the future value of a uniform series 6 years means they're quarterly, so there's 24 deposits, and we're going to have half of the rate of return that the investment manager said we'd get. I don't know how the author solves this problem in the answer key with 1.25% quarterly. I get 1.5% by dividing 12% per year by 2, which gives me 6% per year, and then since it's quarterly compounding, that becomes 1.5% per quarter. So I think it should be 1/2 of 3% or 1.5%. I will grade homework number 3, that's this whole assignment, on the basis of 90 basis points, okay? So if you happen to get this one right, you'll get more than 100%, you'll get extra credit. But I don't think this one is properly worked, and so if you work it properly, you'll probably get the wrong answer, according to my opinion. Now I'm going to work it the way my solution, and then I'm going to show you the author's solution, okay, which uses this 1.26% per quarter. Okay, so the first thing we do is put down what we know. We do know that A it's a uniform series, $20,000 per quarter. Okay, and we know we're going to do this for 6 years, but in terms of the uniform series, that's going to be 24 quarters. Now, the interest rate is given as, and I'll just say rate because I don't know, I don't want to talk about whether it's an effective rate or a nominal rate. I'll just say rate equals 12% per year compounded quarterly. So what I really want to get the future value is an effective quarterly rate. And since it's compounded quarterly, and it says also that you only earned 50% of that, so I'll say that the nominal rate is really divided by 2, so I'll say times 1/2. So that's equal to 6% per year compounded quarterly. So what is I quarterly? The effective quarterly rate. Well, that's 1 plus R quarterly divided by m to the m power minus 1. I keep saying that same formula from equation 3.2 from chapter 3. And now R quarterly is 1.5%, and it's compounded once per quarter, so I quarterly is going to be 1.5% as well. So this is going to be 1 plus 0.015 over 1 to the 1 power minus 1, which is 1.5%. So now I'm going to get the future value of those $20,000 payments. F equals A. Find F given A at rate I for n periods. And A is $20,000 per quarter. And I'm going to multiply that times F given A. And now since this is per quarter, this has to be the effective quarterly rate, which is 1.5%. And this has to be the number of quarters, which is 24. And I can go to my app on Engineering Economics Career app, and I can crank this out. And there's the app, and I'm going to go back to make sure I'm using the right. I need F given A, which is right here in the middle, and then I'm going to put in as the rate 1.5, and as the number of periods I'm going to put in 24. Whoop, 2, 4. And then as my annuity amount, or the A series, is 20,000. And then I tell it to calculate. And I get 572,670. This is not the answer that's in the answer key, by the way. And I'm going to show you the answer that the author gets. He basically does the same calculation, except the author uses the rate 1.26%. If anybody can figure out why that would be correct, please let me know, because I don't feel like it is. So the author basically says F is equal to A, find F given A, but for the rate, the quarterly rate, the author uses 1.26%, and of course N is 24 and A is 20,000. When you use that, you get the answer that's in the answer key, which if you work the problem, I guess you could put this in if you get the same data, and I don't know that you will, but most likely you won't. But the author came up with the answer $556,426. This is a little bit of a discrepancy here because I'm using 1.5% for the quarterly rate, and the author used 1.26%. So that will conclude this problem. The next problem is problem 4 in chapter 3, and it reads, the cost to manufacture a firing system component used in a rapid deployment missile defense system was $22,000 for the first year. However, the company expects the cost to increase by 2% each year. So right away that should ring a bell to you. It's increasing at a percentage rate or a fractional rate, and that means you have a geometric series. Calculate the present worth of this cost over 5 years. So the cost is $22,000 the first year. It's going to go up by 2% every year. And the author and the question is, what's the present worth if the interest rate is 10% per year, compounded monthly? Okay, we better draw this one up a little bit on a cash flow diagram, and I'll put a scale here, which really would run from 1, 2, and so on up to 5. I'm not going to put the whole scale up to 5. We know the first cash flow is $22,000, and we know that after that it's going to go up by 2%. So the next one will be 22,000 times 1.02, and so on across there up to the last one would be 22,000 times 1.02 to the 4th power, not 5th power, because this is to the 0 power when the first one, second one is to the 1 power, and so on. Now I don't have to know what each of those values is. What I do know is I'm going to have a geometric series, and the author says G, that is the rate of change of that series, is plus 0.02. That's from the 2% increase. Okay, and the number of periods is 5 years, and the amount of the first payment, A1, is $22,000. And then the last thing we need to know is the effective annual rate. Well, the rate is given as 10% per year compounded monthly. So 10% is not an effective annual rate. It's actually a nominal annual rate. So this is my nominal annual rate, but I have monthly compounding. So I annual, again using equation 3.2, is equal to 1 plus R annual divided by M to the M power minus 1. Well, again, R annual is 10%, 0.10. M is 12 months in a year. That's how often it's compounded, monthly, to the 12th power minus 1. So this is going to be 1.1 to the 12th power, 1 point something, this quantity, to the 12th power minus 1, which turns out to be, if you do the calculation, 10.47%. So that's the effective annual rate. And that's really the crux of the problem. After that, everything is pretty straightforward. You want to find the present value of these payments here. And that is a geometric series. So P is equal to A1. That's the formula, the symbolic formula for a geometric series. A1 times P given little g. We use little g to represent a geometric gradient at rate I and rate G for n periods. Now this is the interest rate, that's the changing rate of the series, and that's your first payment in the series. This is the number of payments. So this is going to be 22,000 times P given G at 10.47% and 2%, that's your changing rate of the series, and there are 5 years. This is percent per year, this is changing rate per year, that's the number of years, and that's the first payment. You can get this off of your Engineering Economics career app. So I'm going to go there and look for the P given little g. Well, the author doesn't really have that. He has P given A1 and J. Now remember, we used the symbol J to represent the inflation rate. And so we used little g to represent the rate of change of a geometric series. The author uses J for the rate of change of a geometric. So this is the function that we want, though. The second one from the bottom, that's the P given G function. And we're going to have 22,000 here. Well, I already put it over there. I just need to put the answer. So let me put the data in. It asks for the interest rate first, and that is 10.47%. And then it asks for the growth rate, which is 2%, and I already have a 2 there from the last problem, so that's great. And then it asks for the number of years, which is 5. And then it asks for the first payment in the series, which is 22,000. Whoops, I need to go back here. 22000. Okay, and then I tell it to calculate, and it gives me $85,432 if I just round off to dollar amounts. So that's the present worth of this geometric series, and that concludes problem number 4.